Hey students, this is the beginning of a new unit, Unit 8, and this is the unit that goes into trig and right triangle math and geometry that deals with Pythagorean theorem, Pythagorean triples, the converse of Pythagorean theorem, do the numbers even make up a triangle, things like that. So there's a lot of information that you're going to get from this. So we're going to jump right in here. I'm not really teaching you the Pythagorean theorem. We have used the Pythagorean theorem already in this class, and you know how to use it. You know how to identify which one is the hypotenuse, which one is the leg. Now we're just going to take it and apply different problems to it. Okay, so you have this little card. This little card will be returned to me, so it is not yours to keep. And this little card has not all, it goes for infinity, but it has common Pythagorean triples on it. You will have a quiz that will be all Pythagorean triples, and it will be kind of timed. So you have to start memorizing Pythagorean triples. And you're like, what, I have to memorize this whole chart? Not really. These are the common Pythagorean triples here. And if you look on the chart, they're in red. So 3, 4, 5. What this is, these are the legs of a right triangle. And if you put this in the Pythagorean theorem, 3 squared plus 4 squared will give you 5 squared. So a 3, 4, 5 is one of the most common triples that we have. The ACT loves to use 3, 4, 5 triangles because you don't have to use the Pythagorean theorem. You automatically know if you see a triangle that has a 5 for the hypotenuse and a 4 for a leg, you know the other leg is going to be 3. You shouldn't have to do the work. 5, 12, 13 is a super common Pythagorean triple. Okay, 5 squared plus 12 squared is going to equal 13 squared every single time in a right triangle. 7, 24, 25, and you can see that is in red right here as well. 8, 15, 17, that is right here in red. And then 9, 40, and 41 is on down here in red. There are others in red that are Pythagorean triples, but these are the most commonly used ones. Okay, well, you're asking, well, what are the things in black? Well, they're Pythagorean triples that are created off of these Pythagorean triples. And yes, you do have to start recognizing some of them. So if I took, I'm just going to make a little chart here. We're not going to do every single one of these, but I'm going to show you how these other Pythagorean triples are formed. Okay, if I took a 3, 4, 5 triangle and I multiplied these values by 2, okay, so I'm going to say times 2. That means this would turn into a 6, 8, 10 triangle. A 6, 8, 10 triangle is a Pythagorean triple, and it is right here. It's in black because what it is it took one of the reds and they multiplied it by 2. So 6, 8, 10 is a very common Pythagorean triple. Well, what if I took that Pythagorean triple and I multiplied it by 3? Okay, I'm just going to make another row here real quick. Okay, if I multiplied it by 3, that would be 9, 12, 15. And again, these are the sides of a triangle. 9 squared plus 12 squared equals 15 squared. If you look in here, it's in black because it's off of the red. 9, 12, 16. Okay, 9, 12, 16 is, wait, 9, 12, is there another one? Oh, 9, 12, 15. I was saying 16. I knew it was 15. 9, 12, 15. There we go. And so that is a Pythagorean triple. 9 squared plus 12 squared equals 15 squared every single time. So if I multiplied this Pythagorean triple by 2, 2 times 5 is 10. 2 times 12 is 24. 2 times 13 is 26. You need to start recognizing these numbers, and 10, 24, 26 is right here as a Pythagorean triple. It's in black because it's off of one of these other Pythagorean triples. If I multiplied by 3, 3 times 5 is 15, 3 times 12 is 36, 3 times 13 is 39. There should be a 15, 36, 39. There it is, 15, 36, 39. Okay, we're going to keep going. If I multiply this one by 2, okay, let's see if we can find one that has 50. Right here, 14, 48, 50. Okay, if I multiply this by 3, let's see if I can find it on here. See, now they get to where they're kind of unusual, and the people who make problems, they like to tend to write the problems with the smaller numbers, but still you need to know that is a Pythagorean triple, and you could ask yourself, well, what goes into all three of these numbers? I could divide out a 3, and then I would know that that's the Pythagorean triple. So really what you want to do is you definitely want to memorize all of these Pythagorean triples, and then if you have a greatest common factor, like a 2 or a 3 or a 4, divide all the numbers by 2, all the numbers by 3, all the numbers by 4, and see if you can come up with one of those originals. Then it's real easy to figure out what the Pythagorean triple is. You don't want to spend your time figuring it. You want to spend your time memorizing it. Okay, so if I multiply these by 2, 16, 30, 34. 16, 30, 34 is right here. And then multiply by 3. Let's see. 3 times 15 is 45. And 17 times 3 is 51. See, again, that one's not too common. Multiply this one by 2. 2 times 9 is 18. 2 times 40 is 80. 82. And then, so that one, 18, 80, 82. And then multiply that by 3. I need to get a 27. Let's see if I can find it on here. There's a 27, 36, 45. That's not it. Let's see. The 3 times 4 is 120. And this one doesn't have any numbers that big on there, so it's going to go off of my chart. That one might be, I don't see any numbers that big over there either. Okay, so 3 times 41 is 123. Okay, so it is possible to come up with Pythagorean triples, but the whole point is we do not want to have to figure these out. We want to memorize them. Okay, so your job is to start memorizing them. Put them on a flashcard and, put 3, 4, 5 on one side, put 6, 8, 10, 9, 12, 15 on the other side, so you know that they're all related, and just start memorizing these. Put 3 and 5 on a flashcard, put 4 on the other side to know that's the number missing. Put 21, 72 on one side, put 75 on the other side, so you can start memorizing the pieces that go together. But you've got to start memorizing these. This is what your triple quiz is going to look like. Okay, so 9 and 15, if 15 is the hypotenuse and 9 is one of the legs, you would have to know that that leg is 12. Things like that. Okay. All right. So down here, these are Pythagorean triples. So I want you to go ahead or are they Pythagorean triples? Here we go. So find the value of x, simplify answers that are radicals, then tell whether the side lengths are a Pythagorean triple. So if they're Pythagorean triples, you don't have to show any work. You can just write down what x equals. If they're not Pythagorean triples, then you're going to have to use the Pythagorean theorem to solve, and your answer is going to be in radical form. Okay, so I want you to find the ones that are Pythagorean triples. Actually, go ahead and work all of these out. The ones that are Pythagorean triples, no work. The ones that are not Pythagorean triples, show your work. Okay, and I'm going to ask you 1 or 2 questions about these problems. Okay, question number 1. So the question that I asked you was, what does x equal? X equals 17. I don't have to have any work. That is a Pythagorean triple. And so what we're looking for is, by the way, I didn't tell you this because I wanted you to use the chart to investigate, but go ahead and write this down as well. 8, 15, 17 is another one. There's basically 6 that are very common. 8, 15, 17 is another one. So 16, 30, 34, and so on. If you wanted to add that in there, you could, but that is another Pythagorean triple, which happens to work on this problem right here. If 2 legs are 8 and 15, then that has to be 17. 15 squared plus 8 squared equals 17 squared. It fits the Pythagorean theorem. So to verify that that is true, if I look over here and I have 2 legs that are 8 and 15, and this is sorted by leg, 8 and 15, then I know the third side has to be 17. Okay, over here, it's kind of hard because the numbers aren't in order necessarily. So looking for an 8, it's right there, but you might have to jump around and try to find what you're looking for. The goal is you do not use this on a test or anything. You have to learn these. Okay, so you will not use this on a test. You have to know them. Okay, I'm going to ask you a question about number 2. First of all, see if you can find anything in the chart for number 2, which you're not going to be able to, and then go ahead and solve for x using Pythagorean theorem. Write your answer as a radical, simplified radical. Okay, so it's not a Pythagorean triple. The definition of a Pythagorean triple is a set of 3 non-zero numbers that satisfy the equation. So they have to be whole numbers. So even though this will work in the Pythagorean theorem, in order to be a Pythagorean triple, the 3 numbers have to be whole numbers, non-zero whole numbers. But anyways, we get the setup is right here. And I get b squared equals 175. I am getting a radical answer. 175 is 25 times 7. And then square root of 25 is 5. So this is 5 square root of 7. All right. So let's look 8 and 12. If I'm looking up here, I am not seeing 8 and 12 anywhere. So we can go ahead and do the Pythagorean theorem. 8 squared plus 12 squared equals c squared. And we get 208. I'm going to take the square root, and I need a perfect square that goes into 208. So if I divide that by 4, 4 and 52, I'm going to try a bigger one. 16 and 13, that sounds good. So I know this is 16 times 13. Square root of 16 is 4. Square root of 13. This is not a triple. Okay, not a triple. All right, 24 and 25, that is up in our chart. So 7, 24, 25 is a Pythagorean triple. I've memorized that. I've seen that a lot in just the work of geometry. And so x equals 7. There's no work to do. And yes, it is a Pythagorean triple. Okay. All right, so let's look at this problem here and just get a little bit of practice with the Pythagorean theorem and a 3-dimensional figure. So if you'll notice in this picture, I've got right triangle here, I've got a right triangle here, and a right triangle here. In order to get the answer for x, I need to know this length here, and I need to know this length here. Okay, and this is all about using our triples. So right away, I know this is a 6, 8, 10. Because that is off of a 3, 4, 5 triangle, 6, 8, 10. And then over here, 8 and 17. Notice 17 is the hypotenuse, 8 is a leg. And so 8, 15, 17. 8, 15, 17 is another triple. So the triples that I used, 6, 8, 10, and then 8, 15, 17. Those were the triples. No work to show if you memorize the triples. If you don't have them memorized, you have to show the work. Okay? And don't use this as showing your work. You legitimately need to memorize them or show the work. All right, now To solve this, I've got 15 and 6, and that's not ringing a bell. So I'm looking to see on my chart, the only one that has a 6 for a leg is 6, 8, 10. And I don't see any others that would fit. So this is going to be Pythagorean theorem. So we're going to say 6 squared plus 15 squared equals c squared, because that is the hypotenuse. $261. 261 is an odd number, so I can't divide it by 2. Remember I told you that if you divide the problem by 2, divide the problem by 3, to see what you end up with might help you find that perfect square, okay? Do y'all know the rules of 3? That if these numbers add up to a number divisible by 3, then the number is divisible by 3, 6, 7, 8, 9. So I'm going to see, oops. Okay, so it gives me 3 and 87. And then I divided that by 3 again, and it gave me 29. And so there's a perfect square right there. That means 261 is divisible by 9. 9 and 29. Okay, so that was a little bit harder for us, but we're going to take the square root, and this is 9 and 29. And so C is going to equal 3 square root of 29. Okay, so when you look at problems like this, you are very capable of doing them. Okay, let's talk about the converse. So we have learned in geometry that the converse is the reverse statement. If two angles, let's see, if an angle measures greater than 0 but less than 90, then it's acute. The converse would be if an angle is acute, then it measures greater than 0 and less than 90. Okay, so it's switching the hypothesis with the conclusion. Well, the Pythagorean theorem, okay, is this. The Pythagorean theorem says if, I'm going to write it over here, if you have a right triangle, then a squared plus b squared equals c squared will work for the sides of that triangle. Okay, so the converse is going to say if, it's right here, if c squared equals a squared plus b squared, please notice that it's written backwards, then triangle ABC is a right triangle. Okay, so the converse, what we're doing is you're going to be given the values and we're going to ask you, is it a right triangle? Well, what if your answer is no? Well, then we're going to check to see if it's an obtuse triangle or to see if it's an acute triangle. Okay, so if the squares of the lengths of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. That is the converse in words. It's a lot of words. Okay, so I'm going to give you the basic rule. Okay, and we'll talk about this in just a minute. I see that right there. All right, I'm going to give you the basic rule. We will have the Pythagorean theorem written backwards. We are going to be questioning what goes here. In fact, every time I ask you a problem, this is how I will set it up. If you put an equals in there, then it is a right triangle. If you put a greater than in there, then it is an obtuse triangle. I'll explain that to you. So I want you to imagine that this is right. I'm going to put my pencil up like this. If a squared plus b squared equals c squared, then this would be a right triangle. Okay? If I take that angle and make it bigger, what it has done is it has made c bigger. Okay, because the angle is across from the side, they're proportionate to each other. So if c squared is greater, it's gotten bigger than the sum of the other two squares, then it's going to be obtuse. If it is less than, then it's going to be acute. Okay, think of a right triangle right here. Think what happens to C if I make that angle smaller. This side has gotten smaller. So if it is less than the sum, because if it's equal, these are equal, then it's right. So when we go smaller, it's making it an acute triangle. When we go bigger than this, it's making it an obtuse triangle. Okay, so I'm going to bring this 9, 12, 15 right here. Okay, so if I want to see, this one goes with this problem here. If I want to see if it's obtuse, first of all, we are using the converse. C has to be my biggest side. 7 squared and 7 squared. What I am going to do is I'm going to get the numbers for left and right, and we're going to see what sign over here, what symbol would go in between them. So this is 100, and then 7 squared plus 7 squared is 98. Because I can put a greater than, this triangle is obtuse. Because this is representing the c squared. If c squared is greater than a squared plus b squared, it is obtuse. All right, over here. So the 16 is my C. A and B, it doesn't matter which is which. (16 squared is 256. (10 squared plus 13 squared is 269. And then you can see that 256 is smaller than 269, so this is acute. All right, and then if I have c squared, a squared plus b squared, 15 is my c squared. 9 squared plus 12 squared. So this is 225. And then when I put 9 squared plus 12 squared, oops, wrong button. 9 squared plus 12 squared, 225. So that's why this turns out to be a right triangle. Okay. All right, now, there are going to be some problems that they give us where we have to first determine, is it even a triangle? Okay, because we have determined before that sometimes you can have the sides and they don't even make a triangle. So what we have to check is to check the two smallest sides. The sum of the two smallest has to be greater than the third. So the first thing I'm going to do is I'm going to check to even see if these are triangles, and then we're going to tell, are they acute, obtuse, or right? Okay, so this gives me 16. 16 is greater than 11. If you need to write that down, the two smallest have to be greater than the third. Two smallest added together have to be greater than the third. And so this is a triangle. So now we're going to go, I'm going to do this right here, c squared, a squared plus b squared. And I want you to put the 11 here and the 8 here, and I want you to tell me, is it obtuse, acute, or right based on your work? Go ahead and do that for me. All right, you should have got 121 and 128, which makes this acute. By the way, this is the converse. The c squared has to be over on the left. It has to come first in the formula. If you had it reversed, you would miss every one of these problems because it has to be c squared. Everything is determined off of the c squared. Okay. All right, number 2. First of all, we need to see, is it a triangle? So if I add these together, 14 plus 5 is 19. This is not a triangle. If it's not a triangle, you can't tell me if it's obtuse or acute or right. The two smaller sides have to add together to be greater than the third side. Not equal to, has to be greater. Okay. So number 3. Okay. Now, the only way really to tell this one is to look at the decimals. So you can get the decimals in here, or you can say, what is the square root of 5 plus the square root of 6? I want you to notice I'm underneath the radical and I arrow over to get out of it before I continue. So make sure they are individual radicals, and I can help you with that if you need to know. So that is 4.68 for the two smaller pieces, and I'm going to see what that is compared to the square root of 11. So they are bigger than the third side, so I can continue. Okay, so number 3, we're going to say c squared, a squared plus b squared. Square root of 11 squared, and this is square root of 5 squared plus square root of 6 squared. Pay attention to how I wrote that. Now this is super easy because what happens when you have a square and a square root? They cancel each other out. And this is going to be 5 plus 6. You need to write that down. 5 plus 6, which is 11. These are equal. So that means this is a right triangle. And that's your answer. Okay. All right, number 4. I'm going to go ahead and tell you it is a triangle. And look, even though that has something attached to it, that means it's bigger than 4. 4 plus 4 is 8. So I can kind of tell it is a triangle. So my question to you is it right, acute, or obtuse? Go ahead and figure that out. Okay, so we get obtuse. All right, so when you remember, this is why we learned this the previous day. When you square this, this is 4 squared, which is 16, and then the squared and the square root cancel each other out, so it's 16 times 2. 32 plus 16 is 48. 49 is greater than 48, so it is obtuse. All right, I don't know if you noticed this little problem right here, but finding the area, I have the base, I need the height. So when you have, this is called an altitude. An altitude is dropped from a vertex and it is perpendicular to the base. When these two pieces are equal, that means it breaks in the base into two pieces that are equal. So each of these pieces are 9. I need to figure out what h is, and I need to see if that's a Pythagorean triple. Okay, so I've got 12 for the hypotenuse, 9 for a leg. 12 for the hypotenuse, nothing is showing up on here. 12 for the hypotenuse, 9 for the leg. So we're going to do the Pythagorean theorem to see what the height is. So 9 squared plus b squared equals 12 squared. See what I'm doing there? 12 squared minus 9 squared gives us 63. Square root. 63 is 9 times 7. And so take the square root of 9. So that height is 3 square root of 7 is my h. Okay, I am going to come down here to the bottom. All right, area equals 1/2 base times height. Area equals, my base is 18. 1/2 times 18. My height is 3 square root of 7. Okay, remember you can only multiply numbers that are on the outside or numbers that are on the inside together. So half of 18 is 9. 9 times 3 is 27. So my area is 27. Do we have units? We do. Inches squared. Area is 27 inches squared. If I asked you for the perimeter, it would be 18 plus 12 plus 12. If I asked you for the area, it's 1/2 base times height with radical answers. Okay, oh, I left my 7 off. Excuse me. It's 27 square root of 7. There we go, 27 square root of 7 inches squared. Okay, flip over here. So this is Pythagorean theorem with some bigger problems. Okay, so let's jump into this. If I want to find this piece here, I know this is a rectangle, and so this is my x as well. So this is going to be x squared plus, oh, that's my leg, 12 square root of 3 squared equals 24 squared. It's the same thing we've been doing. You're just going to have radicals. All right, so this is x squared plus, all right, 12 squared is 144, and then 3 radical 3 squared is 3, so it's 144 times 3, 432. And then 24 squared is 576. So we get x squared equals 144. We're going to take the square root. X equals 12. Okay. All right, number 2. This is a square. So if this is x, this is x. X squared plus x squared equals 18 squared. 1x squared plus 1x squared is 2x squared. And that gives us 324. So on a problem like this, you have to divide by 2 before you take the square root. So divide by 2. And now we need to simplify the square root of 162. All right, 162 is 81 times 2. 81 times 2. So that is 9 square root of 2. So x equals 9 square root of 2. All right, next problem. X is the altitude. So you now have had that word, altitude. Is that segment there? That segment is going to be perpendicular. X is what we're trying to find, and it does break the 18 in half when these are equal. Okay, so basically I've got a 9, a 15, and an x. 9, 15, and x. Seeing if there's any with 15. Yes, so that is a Pythagorean triple. So this is 9, 12, 15. 9, 12, 15. It is off of the 3, 4, 5. Okay, 9, 12, 15. So that means x is equal to 12. No work to do. You could do the Pythagorean theorem. When you get those whole numbers, you're dealing with Pythagorean triples. Okay, so this is a trapezoid, and we are solving for x. And let's see. Okay, here we go. Sorry, I had to go fix something real quick. This problem right here, we need to put this right angle in order to make this work. So sometimes when you have these problems, it is impossible for us to find this value based on the fact that this is simply a trapezoid. We have to break this into other pieces. So what happens is, if you drop this segment, what have you just made over here? You have just made a rectangle. And so I know this is 24 and I know this is 16. So now we can get this piece right here based off of this triangle, because this is going to be an altitude as well. Okay, we're dropping it down. And it's going to be perpendicular because this is a right angle here. So this has to be a right angle here. This is one of our Pythagorean triples. 7, 24, 25 is a Pythagorean triple. So what is that? 16, 23. So x equals 23. So you guys have to think outside the box. Think of how sometimes you can cut shapes together, cut them into 2 different shapes to be able to find the pieces that you need. And that takes a lot of visualization. Okay, almost done. Number 5. So I want you to see the triangle there. Okay, we're given this information. If AD is 12, let's put that in the picture. And if AB is 16, oh, AD is 12. I'm sorry. AD is 12. AB is 16. Fix that. Then DB is. So I want you to notice there's a right angle right here. And so this is a right triangle. Is there a triple that has 12 and 16 in it? I kind of remember that. It's kind of like 3, 4, 5. This is 3 times 4. This is 4 times 4. So this is 5 times 4. See how I didn't even have to look that up? So this is going to be 20. And then they tell us DH is 15. Okay, so we want to find HB. Well, is that a triple? 15, 20. Let's, I'm kind of seeing a 3 and a 4 here. This is 3 times 5, 4 times 5. So this is 5 times 5, which is 25. Guys, 3, 4, 5 triangle was used twice in this. And I didn't have to do the Pythagorean theorem once. The Pythagorean theorem is a way, or the triples are a way to get to the answer quicker without having to use the Pythagorean theorem. Okay, let's look at number 6. We are given that the perimeter is 100. This is a rhombus. So that means if this adds to 100, these are each 25. We are told, and all these, I'll put it all the way around. Okay, we are told that diagonal TR is 48. So that means this is 24 and 24. Okay, and then I've got, remember, a rhombus has a right triangle. So we want to find what PM is. Does this look like one of our triples? Okay. Does it look like one of our triples? 7, 24, 25. We saw that over here. 7, 24, 25 is a triple. And so PM is 14. Okay, we are done with these notes. It took a little longer than we needed to, but we are done. You guys have lots of good examples. You're going to get lots of practice with the Pythagorean theorem and the triples. The one thing that I do want you to remember is that when you're looking at these problems to tell whether it's acute, obtuse, or right, you first have to see if it's a triangle. If it's not a triangle, remember that does happen. Okay, the last page, I just put some of your triples down again. It's just another place for you to look as a quick reference. Okay, so there's nothing to do on this page. Thanks, students.